Good evening, everybody. A warm welcome.
Good evening.
On behalf of the chair, Mr. Prashant Sutaria, I, the co-chair, Rumi engineer for the Mumbai chapter, have a pleasure and privilege to introduce Dr. Architect Roshni Udyawar. She is a practicing architect and academician whose core competency is energy efficient and environment design of the buildings. Roshni has a PhD in resource management and is a qualified master trainer and empaneled expert on energy conservation building code of India, awarded by Bureau of Energy Efficiency. Dr. Roshni is the president of Institute of Environmental Architecture and Research, IER Mumbai, co-chair ASSOCHAM GEM Maharashtra chapter. She is the director. Roshni Udyawar and Associates Mumbai and advisor Environment and Sustainability, Science and Technology Park, Pune. Roshni was principal investigator for the Department of Science and Technology, Government of India research project on developing energy efficiency and ECBC compliant opaque wall assembly for hot and dry, warm and humid climate from 2017 to 2021. That's where the research has happened. She is a member, All India Town and Country Planning Board, AICT, Government of India. Earlier, she was head Rachna Sansad Institute of Environment Architecture from June 2003 to 2017, where she initiated several environmental projects in addition to postgraduate course on environmental architecture. She has more than 20 years of experience of academic and professional and has traveled widely on a professional assignments to more than 20 countries. Without much ado, I would like to hand over to Dr. Architect Roshni to take it forward. Dr. Architect Roshni, over to you. Thank you.
Thank you, Mr. Rumi, engineer. And thanks for the Forum of Critical Utility Services for inviting me today. I will share my screen so that I can start the presentation. Is my presentation visible?
Yeah, perfect.
Okay. So topic today, as everybody is saying, is interesting. Holistic approach towards built environment. I have tried to put in our practice with a lot of examples, both theoretical as well as practical. Some are still in the design stage, but I've tried to put in this presentation as much of examples as possible. So, we can understand the concepts better. So to begin with, I just want to give a background of where we are in terms of our built environment and as well as the whole global environment. And we know that while India's per capita carbon emissions are low, over the past decade or so, it's been rapidly increasing. And now we are contributing between 1 to 5 billion metric tons of carbon emissions. And we are also rapidly increasing up on the ranking of the global nations, and we are now third ahead of Russia. And you can see very clearly that unlike the developed countries, India clearly has a rising, like you can see 2010 and 2020. So the Indian carbon emissions are on the rise as far as the 2020 and 2010 comparison is concerned. And on the right, you will see this World Meteorological Organization, which produces a report practically every year about the impacts of climate change. And what we have seen is every year the reports are more and more drastic. Apart from the impacts of climate change, such as sea level rise, and melting of glaciers, which is affecting our food security as well as water security. We have some very disturbing sort of things related to the global oceans, that is the acidification. It appears that from the last report that the ocean is 26% more acidic than it was at the start of the industrial era, and that has led to vital marine ecosystems being degraded. And it says that if we continue if we do not take urgent climate action now, then we are headed for a temperature increase of about 3 degrees centigrade by the end of the century. And that will have even more harmful impacts on human well-being. So with this background, we are looking at green or buildings, which, as you know, has huge climatic, has huge impacts on the carbon emissions. Almost half of the global carbon emissions are due to the construction and the built environment, and other factors as well, including the material cycle. 40 to 50% of the total flow, about 3 billion metric tons of raw materials are being used in the building construction industry, apart from the fact that we generate a lot of waste, we pollute water, and so on. So if you look at architecture or built environment, it is next to agriculture in its impact on the Earth's ecosystem. So this is enough cause for us to say that we must design buildings responsibly, and we must take care of the buildings so that they reduce their impact on the environment. So Ecospaces, which is our approach, is aimed at enhancing the quality of life of the users of a space through optimization of the surrounding environment. These are a few works of ours in various sectors, including indoor environment, and some of the examples I will share with you as we go ahead. But our approach is looking at a climate responsive and resource efficient approach that reduces the ecological and carbon footprint of inhabitants, while ensuring thermal and visual comfort, optimum indoor environment, reduction in outdoor and pollution, including noise, as well as making spaces resilient and sustainable, both indoors and outdoors. And it can be scalable from a single dwelling unit to a neighborhood, to a city or a bioregion. And most important of all, it involves deep engagement with the users and also their immediate ecosystem. So there are three cornerstones of Ecospaces. The first one is resource optimization, mainly with respect to water and energy. Today, we all know, we are all familiar with net zero. 10 years ago, or maybe some time back, nobody was talking about net zero. Today, it's a very commonplace. And that is nothing but the same concept that Gandhiji talked about when he talked about Swaraj and making villages self-sustainable. The same concept, but it is in a different, we talk about it in the modern context. So here we are looking at net zero with respect to energy, water, and waste. The second aspect is circular economy, a principle which is again relatively new, but again it is old as far as the Indian tradition is concerned. We believe in reusing, recycling, and so the circular economy principle is also looking at waste as a resource. And there are two things especially that a built environment can look at, that is building materials and also the food, that is the urban farming, vertical farming, and many other things like that. The last corner of the triangle is the improved environment quality, which looks at all types of pollution, especially air and noise, indoor environment, and mainly visual and thermal comfort that we can tackle with. So these are some of the things, and as we go ahead, I will try to show you through examples what we have done or what we have designed. So to start with, let's look at resource optimization. Of course, these are the cornerstones as well: stakeholder engagement, making spaces resilient and sustainable. Resource optimization when it comes to buildings. So I'll start with an example of building envelope optimization. This is a quote from the World Green Building Council, which shows that 39% of all carbon emissions, we said 40%, almost 39%, is because of the buildings. And of this, importantly, 28% is because of space, heating, cooling, and lighting, which means the operational energy of the building. So the remaining 11% is the embodied carbon emissions. So tackling both of these is important, but easier one is the 28%, the operational energy. Again, in the context of India, I just want to point out to you that we still rely on coal as a major source of primary energy, and buildings contribute about 29% in the case of overall all types of buildings in India. So when it comes to resource optimization with energy, our task or our goal is to reduce fossil fuel emissions by making buildings both energy efficient and using alternative sources of energy. So there are three things in energy efficient buildings. One is making the envelope energy efficient. Second is to look at the equipment, which includes the HVAC and all of the things that are the critical utilities, I would say, like the lighting, what kind of equipment, and so on. And if you do these two things, I would say that if you are able to make your building envelope as well as your equipment energy efficient, then you can, design a high performance building. And then at the third stage, you add renewable energy, and that could make your building almost net zero. In terms of the building envelope, I'm sharing with you a design that we recently did of a multi-storied building in Mumbai, wherein we were looking at how to improvise the building facade by adding the shading devices, by reducing the heat gain. As you know, there's very little space in Mumbai. Space is the big constraint, so there's not much one can do in terms of the site and the orientation. Most of the buildings are shaped as per the site. So we looked at this building and we found that the east and west facades were sort of critical in terms of the heat gain. And those are the facades which can allow a lot of heat gain to happen. So the people who will be using this facility later on, that is the residential users, will find a lot of energy guzzling, that is they will be using a lot of air conditioning. So with various alterations based on the azimuth and the altitude and the the kind of shading device that was possible, we came up with various options which would also, visibility is a factor. View is a big thing in Mumbai. So providing the view as well as looking at the shading designs. So we came up with the 4 of these options which provided different levels of shading. And what was finalized was something that resulted in 65% shading of the east and the west facades with material that was having low thermal conductivity and avoiding heat absorption and thermal bridging. So these were some of the considerations that we took into account while designing the shading of a building. This was the final facade. Interesting thing is we also at the same time use this tool called RETV, which is a tool given by the Bureau of Energy Efficiency. It's an online tool for residential envelope transmission value. So we did the calculation of what the base case was, and by using various aspects like including the shading devices and also the change in the material of the glazing and the frames, etc., and the structural cooling system that we designed, how the RETV was being brought down from a certain figure to, so we were able to bring down the RETV, and we just wanted to check how much is the envelope more efficient in that sense. So looking at building envelope, if you see, there is very little innovation, I would say. We still rely largely on fired clay bricks. If you go to all the small towns, that's the material. In cities, we still have options of concrete blocks, AACs, maybe hollow concrete blocks to a certain extent, but most probably we see AAC and concrete blocks as options. And of these, AAC blocks are the ones from the thermal perspective, which are more energy efficient because of their U value, which is considerably lower. So if you look at this, these are the materials that we have today, starting from the CSEB to the various bricks, 230 mm brick, to fly ash bricks, and so on. And you can see that even AAC block is coming to about 0.7 watts per meter square Kelvin. And then this line that you see is actually the benchmark for an efficient building as given by the ECBC, Energy Conservation Building Code. and only with the help of insulation you are able to achieve it. This is of course theoretically just for you to show what our buildings are made of, and this is the reason that we consume more and more energy in the buildings, because these being thermally inefficient, the building begins to absorb and emit heat inside. These are the standards that we have. You can see I was pointing out the 0.4. So all building types, you can see that 0.4 is what is required by the standards. And it's very difficult to achieve that with the given materials. For example, like you saw in the previous slide, concrete is in the range of, if you use concrete blocks, it's in the range of 2.1 or something like that. And brick walls are 1.8 to 2.1. Just here, I have shown an alternative which we generally use in our presentations. If you want to construct, people always say that it's not so easy to make a thermally efficient walling system without, wastage of space. So here, within the same 230 mm, using 115 mm thick brick wall and 75 mm thick inner wall, and having a polystyrene insulation in between, how we could get a much better U value of 0.62. So instead, if you use this 230 mm brick wall, you will get an insulation U value of 1.8 to 2.1 instead of that, with just a small modification. Of course, the cost is there, but then you have to think about life cycle cost, because this kind of a building is going to be much energy efficient, much more energy efficient, and therefore your running costs will be lower. These are just, of course, important points about how the laying of these layers is important, because the sealing of the insulation, all of these aspects, the quality of construction plays a major role in this kind of construction, and probably we still lack in that yet. Another example of the same 230 mm brick wall, how it can be replaced with 115 mm thick brick wall and a very simple insulation covered with gypsum plaster board. So, in effect, the thickness remains the same, but the U value comes down to 0.57, which is, significant. We are very close to 0.44 in that case. So, installation, etc., you can see it's a simple plywood framework in which you fit in the gypsum plaster boards, which are also easily available. Coming to roof, also very important. Of course, maybe not so much in Mumbai, because we have high-rise buildings, and high-rise buildings have much less roof space versus wall space. So in high-rise buildings, wall becomes very important, whereas in the semi-urban or the areas, most of the buildings are low-rise, row house type buildings. So their roof plays a very important role. And as per the standards, we have 0.3, which is very stringent. As you know, a 150 mm RCC slab will have a U value of close to 3.7 or something. So to achieve 0.33 means that your roof is super energy efficient. I mean, this is the basic standard, but that is why the roof allows a lot of heat to come inside the building. So that's a big stoppage of heat flow inside the building, and therefore it makes the building efficient. Here are just a few examples to show you what could be the options. These are all under deck insulation products, and we have calculated the U value for you here, just to show you that by using these materials, it is possible, even with a RCC slab, etc., you can still have, the U values coming to between 0.23 to 0.8, which is also not, which is quite energy efficient. So this is how you can actually put in, you have the slab, you put in the puff insulation in between that, which is above the waterproofing, and beyond that you have the concrete screed with the slope. So it's possible to get that. Again, you can see here that the U value is something like 0.46 as against the typical RCC slab of 3.7. You can do various other things beyond insulation, like you can have an intensive or an extensive green roof, because the minute you have a tree cover or a covering like this, or even a cover like a lawn cover, it immediately provides insulation to a certain extent to your building. And if you have it well watered, especially, you know, if you have an extensive green roof with trees, etc., then it also provides radiant shelter, as in this tree acts like a barrier. You can have reflective China mosaic tiles. The concept is slightly different from insulation because it is more of a solar reflective heat that is taken away from the building. Or you can have a radiant barrier insulation, which is usually requires an air gap between the roof and the the material itself, so that it can work only with that. It's a radiant barrier material, usually a very shiny material with a low emissivity. There are also other options one can look at, like using maybe filler materials like ceramic pots, or even people use a lot of waste mangalore tiles and things like that, which can be inserted, basically using reducing the amount of material that goes into a RCC slab, and at the same time looking at insulating the roof. So that was about the envelope. Coming to the equipment or the energy consumption, which is due to the lighting and the fans and the air conditioning. So generally, this is how we find is the breakup of energy consumption in a building. Now, mind you, here AC looks to be equal to others, but actually the percentage of conditioned space is generally very less. This is from a college building, and you can imagine that only a few spaces are air conditioned, and yet you'll find that, that there is a distinction of this kind. So again, here there is a lot of scope for reduction of energy through energy efficient equipment. And just to show you this as an example, this is the calculated EPI, or energy performance index, of a single residential unit. So you can see that in 2013, with 144 EPI, several changes, including adding a geyser, which is energy efficient, 5-star rated geyser, to a 3-star rated or a 5-star rated AC air conditioner, and then efficient devices and so on, can simply bring it down to 77. That's 50% of the consumption. And this does not include using solar or including any of the building envelope aspects. And yet, by simply changing the equipment, you can bring down the EPI drastically by almost 50%. So that is the potential that we have in terms of energy efficient equipment. And lastly, in the energy sector, the next step, as I said, the first two things, when you do already your building is a high performance building, the next step is to make it a net zero or a nearly zero energy building, which is defined by the Bureau of Energy Efficiency as having an energy performance of about 15 kilowatt hour per meter square per year. So this is, I mean, if you reach to this benchmark, then you can consider that yours is a nearly zero energy building or a nearly zero energy apartment. We do have examples of nearly zero, net zero buildings in India, and that's from our own Environment Ministry headquarters, Paryavaran Bhavan. And major inputs in this building is because of the natural light, daylighting that has been worked out, natural ventilation, and of course the roof having a huge 930 kilowatt of solar panels, which goes beyond the envelope of the building as a shading device as well. So that is what is making this building as net zero or nearly zero. In fact, I understood that it is even positive. It's giving energy back to the grid. So this is a good example, and I think many are looking forward to making their buildings like this. Coming to the second part of resource optimization, I have included here one case study on watershed management. Because generally, when we design or plan buildings, we rarely think about water resources, because at least in Mumbai, we have a very good supply, municipal supply. So we just have to plug into that and we get the water. But what happens when you are not connected to the so-called grid of water. So here's an example where there was a planning of a township in Raigad that was involved, where there was no water supply. The architect had done the layouting, but how will we supply water to all these people whose houses are going to come up, all the recreational facilities that were provided, and so on. We need to source the supply. Of course, you can source it to a nearby river, a canal or something like that. That is always possible, but we tried to do an entire watershed management plan here. And I thought that I can quickly show you what was done here. This was the site. Some of the existing features of the site are shown here. Primarily, you can see that on the one side, there is a lot of dense vegetation. On the other side, it's dry with a lot of rice fields and so on. So we put ourselves this objective that we will provide potable domestic water. We will look at protection of the existing streams and springs because they are critical to the future water supply. Looking at even reducing the flooding and drainage problems. Also, how we could revitalize the ecosystem of the place by preventing soil erosion and controlling sedimentation. And lastly, to recharge the groundwater and reduce the surface runoff. For all of this, we relied on maps laid one over the other using geographic information system. So first, of course, we identified the watersheds, the streams and the various orders. We identified the streams that needed to be protected at any cost. So no construction over these streams. We needed to provide culverts or something which would protect these streams. And even extraction of these streams or groundwater. So overall, we tried to identify this so that we could look at water storage, water transportation options, water recreation, and so on in the site. Also, the existing wells were tested to test the kind of water, the water table, and the hydrogeology of the place. These are the various GIS maps that we developed to find out the kind of hydrogeology, the slope, elevation, where should we have the residential units and so on. And this is just to show you what are the watershed interventions that we came to based on the slope, the stream orders, and the watershed parcels. So, ranging from loose boulders to stone masonry, gully plugs to intermittent contour trenches, percolation tanks. These are percolation tanks were actually the storage for the entire township that was planned, and also the recharge wells, the bore wells. So based on the slope, based on the space, different types of interventions were suggested along in the actual plans on site. What should be done in order to, so whenever it rains, we catch the rain as much as possible. Basically, simple rainwater harvesting techniques. So they could be, these kind of nala bunds, check dams, depending upon, and these are guidelines that are already given by the Groundwater Board. And of course, also working out like a water balance. This is very critical whenever you're looking at a township. So how much does this township require, and how much can we get from nature, that is from rainwater, from wells and bore wells, and how can we recycle and use the wastewater, how much can go into landscaping. A water balance has to be always developed when we look at looking at a watershed or a large township planning, which is done. And then based on that, of course, we looked at interventions in the sites and what kind of recreations could be added and so on and so forth. And then the parcels and phasing was done. So the whole site was divided into parcels, and the blue and green infrastructure was planned based on the studies that we had done using the GIS. So I think that for any township, not just the water balance, but also the watershed management techniques are important for long-term water availability. So that was watershed management. In addition, we can also look at individual buildings or houses of water efficiency by using efficient and devices. Today we have all the technology available to reduce the flow of water, to stop the flow of water, to stop wastage and leakage by using dual flush systems and sensor-based taps, and even water meters to look at how much our water is being used. And of course, wherever possible, especially even in the single units, even if you have a single bungalow, how you can do rainwater harvesting. And it's simple and it's not very difficult to do. Either you can do a storage or you can recharge the groundwater in your particular bungalow. And you can have, these are some case studies. We've done a lot of work in Mumbai with high-rises, single dwellings and so on. So the first one is a housing society in Dombivli, where it used to get only tanker water supply. So, we managed to use the roof water to recharge the borewell, and then they began to use this for their flushing. So at least they got the water for their flushing. Similarly, a gymkhana where we stored water which could be used in the off season for washing and other purposes. And in the third case, an apartment in Worli where we managed to revive an existing borewell using rooftop rainwater, and that was kept as a future supply for the flushing system. Even in modern buildings, like modern high-rise buildings, there is a great option for recycling for doing rainwater harvesting. And in this particular case, we were, it was difficult because the water table was pretty high. And so we managed to do this entirely around it, recharge pits, as well as a storage of about 3.5 lakh liters, both in tanks as well as open wells, and which the recharge pits were designed to build to hold about 70% of peak runoff of 100 mm per hour. So there are challenges with rainwater harvesting, but if we realize that we are taking water supply from really far off places, which comes to our city, and we're utilizing it for recreational purposes, etc., I think it makes sense to use as much water as possible, and not allow it to run off into gutters and into the sea. We can use it on the site for as much as possible. Wastewater treatment is also an option, and this is recently we did a high-rise building on the roof of which we proposed a recycling of the grey water of the multi-story building using reed bed system, which is again using no energy actually except for the pumping of the water. So this was the system in which we used. We had about 167 square meters of terrace in which a 20 KLD system was designed to use the grey water and then reuse it, as well as we had rainwater harvesting also designed in the building, which was used for recharging the borewell, and there was a buffer tank in the roof as well. So that was about energy and water. I move on to the next, which is circular economy. Of course, the circular economy principles are with respect to reducing the waste and using waste as a resource, and how to reduce the overall, embodied carbon of a building material. And especially when it comes to building material, we don't generally see this, but behind the scenes, right from raw material extraction to the time the material comes into the market, there is so much that goes in the background, the energy. Apart from that, there is, so at each stage, there is a possibility of looking at recycling it, reusing, and looking at what are the waste and how they can be put back into the system or put into another system, so that there is a, even in the concrete cycle or the cement cycle, there's so much, like using recycled debris as a crushed sand, or various other options. So there are minute changes possible within the system, within the process, and as well as there are large scale changes also possible, which we should look at. And that is one way of looking at it is the life cycle assessment, which looks at all of the possible effects. On the left hand side you can see climate change, acidification, eutrophication. So if you are polluting the water of a lake by various organic waste, then it can lead to eutrophication, or if there is air pollution, then it can lead to smog, and so on and so forth. So all of these impacts are looked at, and how we can improve at every stage this is a holistic yardstick of environmental performance, the life cycle assessment. And one of the tools that life cycle assessment uses is embodied carbon, which we talked about in the beginning of building materials. And as you can see, some materials are very energy intensive, like aluminium. At the same time, aluminium is also recyclable. So we need to know about that, which are the materials which are energy intensive, try to avoid these materials. And if you cannot avoid it, then use something that is recyclable. So some of them are not recyclable, some of them are non-renewable. So we need to try and reduce the use of these kind of materials and use as much of recycled material as possible. Even in the National Building Code, I just wanted to show you that in the National Building Code 2016, we have seen that there are different categories of materials that have been identified, and even the examples are given with the range of intensity of the energy intensity that has been given. So low energy are given here, and then medium, and so on and so forth. So if you're using, say, cement stabilized earth blocks, which use 90% or so of earth which is available on site, that's a low energy input as compared to, say, bricks or any other input. Sustainable building material can be identified. I mean, these are the various criteria by which you can, any material that is durable, material that leads to low embodied energy or has minimized wastage during its construction or during its manufacture, or which reduces use of natural resources. These are all aspects or criteria for a sustainable building materials. Recently, in the research work that we did, we identified 47 such variables, and we even built a kind of a tool by which to rate a building material as a sustainable building material. That is still in the process of being developed. So, but that's the kind of thing that is required for assessment of a building material. Here, I'm just showing you the various options that exist. Some of them are still in research phase, some of them are widely used. So you can see that rapidly renewable materials, or things like which act as fillers, or which have less pollution, air and water and soil, or which are biodegradable. These are all examples of that. Nowadays, we get lots of materials which are based on coir, bagasse, wood substitutes. These are all options, and hollow blocks, which reduce the overall material usage. This is an example of a house we had done almost 10 years ago, I think, but basically a studio as well as a artist studio, in which we had used bamboo walls, pillar slabs, local stone, bottle walls were used, old doors and windows were used as a material for the windows and doors, and we used mud and cow dung flooring. So, we were sort of using all sorts of materials that had low environmental impact. That is what the artist actually wanted. There are lots of examples of innovations in the building materials. As you can see, these are from Auroville in near Pondicherry, where we have adobe walls, CSCB, these are CSCB walls, is wattle and daub structure, or ferro cement, which are all options against the conventional. There are two examples here again that I want to share with. First one is the San Francisco Bay Convention Center, where the walls are made out of straw bales. You can see the straw bale in one corner as an example, but the entire wall is made out of that. This material provides an amazing temperature balance between the outside and the inside, and you will never be able to make out once it is plastered that what it is made of. It provides also very good indoor air quality, environment quality. And the second example is of a house in the Hisar, Mumbai, where we on the site itself, we recycled all the debris of the old bungalow, which was demolished to produce a G+3 structure. and about 50,000 bricks were generated on site. And we saw to it that no debris goes to the dumping ground, and we used everything either in the form of bricks or PCC or paver blocks. Different things were made and used on the site itself. So that would be a great venture if somebody wants to take this kind of thing up. We had just experimented this one, but there's a lot of scope for it. Waste, of course, is one of the major issues. All of the cities today face a major problem of land waste, air pollution, soil, groundwater, marine pollution, odor, and bioaerosols. Especially in today's day and age, we cannot afford to have this kind of a dumping ground at all. So, I mean, world over, everywhere, there are scientific landfills, and that's what we need to move into. And for that, the first step is segregation, which is not at all difficult, but it all depends on people. So segregation of waste as much as possible, and then recycling the e-waste wherever it is. Of course, today there are lots of e-waste recyclers available, and so you can give your waste. We have worked with a number of schools and set up these e-waste centers so that the students can and the faculty can come and deposit e-waste, and it can be taken by the company later on for recycling. Organic waste also, segregating the organic waste, especially in residential dwellings, residential apartments, houses, bungalows. This is all possible, and depending upon the kind and the quantity of waste, you can go for either organic composting, vermicomposting. Where space is a constraint, even electrical composting, because space is not there in all the apartments and all the buildings. And where you have a lot of organic waste, you can even go for something like a biogas plant. Indoor air quality issues are also important as far as Ecospaces is concerned, where we look at not just the external air. External air and noise pollution are basically the benchmarks for the quality of life of a place. And whenever you have such a situation, the worst is the indoor air quality, because we spend most of our time indoors, and indoor air tends to be 2 to 5 times more polluted than outdoor air, because there is no dissipation happening and the concentration of the contaminants builds up in an enclosed space. So generally, we look at health from food, lifestyle, and the environment perspective. But what we generally don't look at is the indoor environment, which also plays a key role in our health. There was this very famous cover page called "Is Your Office Killing You?" That's way back in the 70s, the idea of sick building syndrome came up, wherein is your building making you sick? And actually it did. There was a lot of research done on this, and they found that buildings which have non-cleaned air conditioning ducts and which have no ventilation and which have poor lighting can cause a lot of damage to people, and all the respiratory tract ailments and various other things were identified, including chronic issues like cancer, but also part of the sick building syndrome. So there are various indoor air pollutants that we need to be aware of. Most dangerous are the biological ones, which can be in the form of allergens or dust mites on your different parts of your, it can be on your carpets, your fabrics, and so on and so forth. There are also chemical pollutants which are dangerous, especially the VOCs, such as formaldehyde, which is one of the dangerous ones. And there are physical pollutants as well, including sawdust and many other fine particles which are generally released and which we are not aware of, including asbestos is also one of the pollutants that is left. This is a typical office, and you can see different types of VOCs from the cleaning solvents, VOCs from electronic equipments, VOCs from carpets, because carpets are sometimes pasted with adhesives. So we have found in some cases that carpets are the biggest sources of VOCs. There are fine particulate matters which are left out even by photocopiers and printers. There are dust mites on furniture, fabric, and so on. Biological contaminants if the AC ducts are not properly maintained. So these are various things that can be there. In addition, if you want to look at overall health of building, we need to look at it from a holistic perspective, including brownfield sites. We have seen various examples of buildings which have been built on dump yards, for example, and there were corrosion of all the electronic or the electrical equipment, and there was poor air quality inside and so on. So it's not just those things that I've shown you. Beyond that, we need to look at all of these aspects in order to make buildings to be totally healthy. Here's an example. I used to take the students of my master's program here to show that even in a high-rise building in Mumbai, in Kemp's Corner, on the upper floors, there was a design of a house which had a cow dung flooring, which was made out of lime plaster. They didn't use electricity, only castor oil lamps, and very little of electricity consumption was there, mainly because they used materials. Even no adhesives were used in the entire house. It was a traditional design, and the main benefits were in the indoor air quality of this building. Indoor air quality can be improved by using plants. This has been well proven now. During my academic years also, we have done a lot of research with students which showed that in using of plants can reduce the VOCs, can reduce the temperature levels inside. So within the, as NASA says, within the 1.5 square meter around you, if you have plants, then definitely there is a benefit to you in your indoor environment. So plant as many plants inside as much as you plant outside. In terms of improved environment quality, I just want to show you two quick examples of what can be done, especially from the visual, acoustical, and thermal environment. So of course, you can use a lot of different passive design strategies, which is one of the major focuses of our work. So that if passive design strategy is basically a strategy by which the operating energy of the building is reduced without having any extra cost, with just the minor interventions such as solar chimney or shading devices, wind scoops. So you saw the example of shading device right in the beginning, but there are many other things that can be done, such as geothermal cooling. We have also worked on this thermodrain system. So I'll show you the example of thermodrain system where we did an assessment of thermodrain and how effective it is. First example I want to show of a college building which we entirely retrofitted because there were thermal comfort issues on the 6th floor. So in addition to the refurbishment and the renovation that was required, we also worked on the thermal comfort aspects. So among the changes that were made included the introduction of dry walls for partitions, which had sound and thermal insulation, very important for classrooms. We used high albedo paint, which were having a solar reflective index of greater than 5. This again reduced the cooling load. We provided radiant barrier underdeck insulation, which has, of course, low emittance and low thermal transmittance. And we used the turbo ventilators for inducing stack effect, for which we also had to remove the false ceiling of the place. And we introduced translucent polycarbonate sheets to allow light within classrooms from outside to the classroom, and also to get skylights to get the light in. And spatially, we, these measures were mainly done for cross ventilation and stack ventilation, improving them because the building was right next to the close to the Arabian Sea. So, getting the sea breeze was important. We removed the false ceiling, we increased the window to wall area ratio, and provided singly banked rooms. So this was the pre-retrofit section of the classroom, and then this was the removal of the false ceiling, allowing the stack ventilation, improving the circulation of air throughout, and then using the roof, because the roof was a major source of heat gain. So we made the roof more efficient by introducing a radiant barrier, by adding the high albedo paint, and then we also introduced the turbo ventilator. So these are pre and post pictures of this building. You can see there was a false ceiling. We removed that. We created more space, let the air to go out from the stacks. We introduced skylights. So we also did a post retrofit, pre and post retrofit study of this, because that was also part of our how much the building actually improves. We also did PPD studies for the thermal comfort. But what we found that within the next, season, after the retrofit was done, we found that there was a 12.6 degrees centigrade bottom under deck temperature below the roof, and that helped in reducing the overall mean radiant temperature inside the spaces, and the spaces were much more comfortable. The second example is that of a TOD system, thermo drain system, which is which reduces the use of air conditioning at all. There was no air conditioning in this building, office building in Nashik, ground plus 2-storied, 2,834 square feet. And you can see this is the putting up of the pipes. So what these pipes are done, they are embedded inside on top of the roof, and the water is circulated through them. The system is designed to remove heat from the structure, about 242 BTU per square feet per hour. They are connected to an underground tank from which the water is circulated, and the idea is to absorb the heat and put it into the tank, and then so there is a sensor which tests the temperature of the water, and the water is again recycled whenever the temperature goes beyond a certain level. So we did an entire testing of the system, and we found that the system is, in terms of EPI, this building had very low EPI, beyond like 24 kilowatt hour per meter square per year, which is very low. And also we saw that in terms of the capital cost, etc., and the life cycle cost, so it was 10 times less than the conventional. The capital cost was 50% of a conventional, and overall the energy cost was also low. So this is how we looked at assessment of the system, not just the cost, but also we looked at the thermal comfort assessments of the TOD system. And we published this paper also internationally. It has received the best paper award at the CLIA conference in Hong Kong. A similar example of passive design is this IGP complex in Gulbarga, where passive cooling has been achieved through these wind towers that you can see on the top. Basically, they take in the air, and there is a sprinkler system which is put on the top, which provides the cooling for the entire building. So no air conditioning again in this building, but a very well functioned for many years. I have taken batches of students to see this building. It's a very good model of evaporative cooling. Of course, maintenance is an issue with it wasn't maintained by the owners and users, unfortunate. But of course, it can be. It is possible for anybody to do this. So, lastly, I would like to talk about Green Campus, which is an initiative that we, take up with in the schools and colleges, which we have done in the last few years. There's a very good scope in colleges to make them net zero, especially with our commitment now at COP26 and so on. But we found that these buildings are, first of all, they are most of them have very good, are very good in terms of the design, in terms of the envelope with the corridors as buffers, and so a lot of passive strategy. You can see natural lighting exists. But at the same time, we found there's lots that can be done with respect to the energy efficiency and use of renewable energy. There were some buildings where up to 20% of energy were done through the solar energy. So this is a great possibility and a great for the future, I would think that almost all school and colleges can become nearly zero, net zero buildings. And also we found their EPI to be not very high unless they are fully air conditioned. A couple of schools and colleges we found which had gone fully air conditioned had up to 54 EPI, 54 kilowatt hour per square meter per year, which is on the higher side. But otherwise, most of them were below, even 20, I would think. So you can see very clearly that here's a conditioned space in C2 college, and again, the annual energy consumption and the EPI are higher. So the minute you have a building which is air conditioned, the overall impact of that building, the overall energy consumption increases. So typically colleges do not have that, but in some cases we also found that where they have, they were not having very high because of various reasons, usage and being very careful with how they use and so on. But there is a great scope in terms of light, fans. Of course, we can't do much retrofit in existing spaces. So some places are using lights all the time because of non-availability of natural daylight. But most of the spaces are, you can do lots of improvisations in terms of energy consumption. Standards and benchmarks that we refer to, we of course look at the National Building Code, which provides with the Chapter 11, which is Approach to Sustainability in the National Building Code 2016, gives us a whole lot of guidelines for sustainable building design. So these are all there as a benchmark. We also have the Energy Conservation Building Code, both for the commercial and the residential sector, which stand as, and then we have the B star rating, which also provides a benchmark for the EPI of different types of commercial buildings. We also have a star rating now for residential buildings. So, individual units, apartments can all also try to achieve this. Apart from that, there are various other rating systems as well, of course, which everybody knows of. Now, quickly, I want to end with a few models which are inspirations of sustainability. The first one, in terms of retrofit, I always give this example of the Empire State Building in New York, because although it was built at the time of 1930s, it did not have any concept of energy efficiency or energy conservation. So it was, truly speaking, an energy guzzler building. But I think in the early 2000s, it was the retrofit was undertaken, and by various measures, including changing the 6,500 windows from single glaze to triple glaze, changing to energy efficient chillers and radiative barriers and so on, they managed to reduce the energy consumption by almost 38% in this building. This is a new building, the Potter School of the Potter Institute of the Tel Aviv University, which has very interesting features. Now, for example, the southern facing wall is called an eco wall, which has got solar vacuum tubes, which absorbs the sun's energy and heats the water that flows in the tubes. And this is the main source of energy for the building's air conditioning system. In addition to that, it has also a natural passive ventilation system. So there are air vents which are designed to allow wind from the sea to flow across the building, and they open automatically by temperature sensors. We take in fresh air, and the hot air is ventilated out using the solar chimney on the top of the building. So there's constant flow of fresh air in the building. There's also a green roof, which has various plants and vegetables grown there. There is a water recycling system right in front of the building. So the entire water of the building is recycled there. These are some, all the material, the furniture is recycled. There are various, of course, examples like this, but in educational buildings, this is a fairly good example. When we look at cities, the challenge is even bigger, because we think that that's where the major battle against climate change will be fought and won. So the Mazda city, in that sense, is a very interesting was one of the first, designed by Sir Norman Foster, was one of the first designed net zero cities. They had a 10 megawatt plant in the desert, of course. But also all the buildings were passively designed. You can see this naturally ventilated jali. There were solar panels on the roof. Very, very interesting features, including a transportation network below ground, which was entirely from electricity, which was taken from solar. So, and apart from that, there are many others. Sustainable communities like Freiburg in Germany. There's a very, very good example. Where the EPI of most of the houses is not more than 15. There are Oroville in India is an example of how sustainable communities can be done. There is Gaia Eco Village and many other eco village in the eco village network in Finland, Australia, and so on. Of course, in India, many of the older cities are also very good examples of sustainability because of the way they are built. Not only with respect to climate, but also with respect to water and energy resources. They are very, very well designed, and we have a lot to learn from these traditional buildings in India. Quickly sharing with you, because I mentioned about the stakeholder engagement. So a project that we did for the state government on village tourism in Sindhudurg. This was with the Rachna Sansad Institute of Environmental Architecture, where we had developed a master plan for sustainable village tourism in Sindhudurg district for 21 villages under 5 circuits. We had looked at a lot of stakeholder engagement, was very much a part of the entire exercise, where the students, faculty, we interacted with all the people in all these villages, 21 villages, to create the master plan, and that was submitted to the Rural Development Department. So, at various stages, of course, right from the beginning till the end, when the designs were completed, this was very much a part of it. Another example I like to share is the design of a Anganwadi and school toilet that I had done along with the Israeli industrial designer Tamar Akov, where we looked at all of these principles of green design, but at the same time, we also had a lot of engagement with the students of the primary school in understanding what they required and what were their ideas of designing of a toilet, and so on. So this aspect about stakeholder engagement that I mentioned is what was important for us in this particular example. I think that brings us to the end of this holistic approach to design. And I want to quote from H. Kumar Vyas, who said, design in the final analysis is an agent of change to enhance and improve our material, psychological, and socio-cultural environments while maintaining harmony with the ecology of our planet. Thank you.
Thank you. Thank you, Dr. Roshni Udyawar. Wonderful sessions and very insightful. And I wish we had many more participants and architects and developers and city planners for this program. I'm sure we will have maybe the second series or the third series, wherein we'll try to get all the CEOs of the smart cities and city planners for this. And I have my colleague, Mr. Daruwala, the Vice Chair of our electrical vertical, then our Vice Chairman of Mumbai Chapter, Rumi, who has taken a lot of effort in promoting this event. Maybe before we ask our other panelists to join in, Nikhil Kumar has been very actively posting certain questions. So he's the only person who posted the question. Let's see whether this question will be quite interesting for you. I think you can also see these questions. What is the standard for VOCs in furniture and carpet in India we follow? Green Seal and Green Guard is international number.
Yeah, I think for furniture and for generally the green guard is one very well-known standard, and even in India we had done this research work for Godrej Interior, and at that time we had looked at green guard as a sort of a benchmark. So I don't recall the exact ppm, but we referred to that, and what we had found was that several of the indoor office spaces, open offices especially, that we had done the survey were much above the benchmark, and the reason was the use of certain materials which we should especially the plywoods and the carpets were the major source, paints also to certain extent. These were the major sources. So that was the green guard is a benchmark that is referred. Apart from that, there is BIFMA as well, which is also related to furniture. And these are the two things I think we refer to.
Mm-hmm. Again, question from Nikhil. What is the FAR of this project?
Which project are you referring to?
I'm Nikhil. I will allow you, since you've been active here, I will allow you to speak. I'll just see whether I can put you, Nikhil here. Yeah, allow to talk. Yeah, Nikhil, you're on board with us. If you're referring a specific project, you can talk.
Good evening, sir, and good evening, ma'am. I wanted to know the FR of the first commercial project which you have shown, ma'am, in the presentation.
FAR is in the floor area ratio?
Yes, ma'am. Yes, ma'am. Exactly.
See, I was involved as a green building consultant. So my role was to make the building facade and everything as much as environmentally sensitive as possible. My guess is that being a residential project, this and in Santa Cruz, so I guess the FAR is as per whatever is there in maybe 1 or 1.3 or something like that.
Yes,
it will not be beyond that in any case, and builders tend to use full FSI as far as Mumbai is concerned to get the maximum benefits and profits of this thing. Plus the builder was investing a lot of green infrastructure in addition to these. So I'm sure that they have used the full FSI that was available. It was a small plot of land in any case, surrounded by buildings on all sides.
Yes, ma'am. Ma'am, also, ma'am, the transportation facilities which you have used in the construction of these projects, there is no focus on the clean fuel on the emissions given by the transportation vehicles, right? Especially.
Well, we were not involved in any project where we had to look at transportation per se, but yes, in green campus projects, we do we have a matrix for calculating the carbon footprint, and we look just at two aspects: electricity and transportation. So wherever the schools are located close to a public railway station or a bus stop or something like that, definitely they score much more, because most of the students and the faculty, they travel by public transportation. Whereas in many of the cases, like even though the building may be green, etc., because they have so much of transportation buses that they have to use, they have no choice, because the students cannot come one by one. So they generally use buses, and most of them use petrol and diesel. So generally the footprint of these schools is much higher when we calculate the carbon footprint, and we tell the school that we are looking at only these two aspects. So in this case only, I think the transportation aspect has been considered by us. In most of the cases, we have otherwise looked at green design with respect to the building, with respect to the site, and so on.
So Nikhil is also
especially
checking with energy consumption of this project. Nikhil, your question was, what is the baseline of energy consumption when we do green? Is that correct?
Is that question to me or to Nikhil?
No, Nikhil is asking
Okay.
basically energy consumption of these kind of projects. So what would be that? The traditional, say, electricity bill, are we talking about 20% reduction or the 30% reduction?
Well, I don't think there is any such kind of a target. The target is to generally, when we do design and there is a clear brief from the client that they want to go towards net zero, then our target is to come to that 15 kilowatt hour benchmark, wherein, after all the net and everything, renewable energy efficiency aspects that we apply, the building consumes either zero, which is nothing, or else something like maximum up to 15 kilowatt hour per meter square per year. That's the sort of benchmarks that we look at.
Roshni, Dominic ji, I can, sorry, I would like to add over here. See what happens, we do the energy modeling, no, Roshni? And
Yes.
we work out a baseline. So we follow this ISHRE or a ECBC, whatever it is, it depends on the project. And once you have a baseline, when you are designing, you do better than the baseline. And that's how this entire process works. It's the electricity bill is after the construction is done, you occupy, and the way you use it, that's a very different issue. But to ensure that your building is much, much better than a conventional building or a normal building, which is not a green building or which is not gone for certification. So this gives you a very good tool to understand where your investment will be and what are the returns for your investment. Like ma'am showed that bricks, these are one-time investment, the building envelope, it's only one time. But that gives you a benefit for next 40, 50 years for the life of the building. And it also has a cascading impact on reducing your air conditioning load, your contract demand from the supply company, and so on and so forth.
No, what I saw that one of your slide, Roshni, the pot roof, which you are showing, which we did in one of our farmhouse. The problem, the design is good, the architect gave, but the skill to do that is what we lack. We have to use the current laborers or masons they don't understand this. They got used to the steel rod and the roofing. When we there is a lot of issue on the skill laborers to do these kind of projects. Don't you agree with that?
Absolutely, absolutely. I think the major problem with respect to energy efficiency design, energy efficient design also is craftsmanship, tools, skills to be. So I was like, when we have this meeting of the master trainers and the Bureau of Energy Efficiency, I've often said that rather than training engineers and all the people who come much later, we need to have skill training for even how to put up insulations and things like that for a lot of the worksmen, people who work, contractors. These are the people who are typically used to construction of the typical nature. So whenever you have anything which is different, neither do they understand why we are doing this, nor do they understand how to do it. And I don't blame them because they're not trained in that. So I think some amount of inputs need to be going towards training them. I remember that a long time back at Rachna Sansad, we worked with HR Johnson. So they had training for local masons, etc. They used to do it free of cost, but how to apply tiles, how to properly so that there is no leakages and things like that. I think this kind of a training is very crucial, especially when we talk about energy efficient buildings. And I just want to add to what Pumi sir just said about the baseline. Yes, when we are doing buildings, that is designing new buildings rather than retrofitting, then we use energy simulation, for which the model or the baseline is the prescriptive approach or the prescriptive tables that are given in the energy conservation building code. So we use that, and that becomes like our baseline, and we have to make minimum standard of that, and then our proposed building has to be better than this. So
we have Satish Iyengar, who's our treasurer and also well-known MEP consultant. So he's asking question: what is the cost of the school toilet done by you?
I don't have the cost right now with me, unfortunately. I can definitely dig it out and give it to you because it was done quite a few years ago. But it was just about conventional or less than conventional because we did it as part of a CSR project. So we had huge constraints on the cost aspect. So every bit of material that we introduced there was very, very carefully thought of. So it wasn't a fancy toilet. It was a regular toilet, but we tried to make it as environmental design as possible.
So he's also asking, what about the use of porothermic hollow tiles to reduce the heat gains from the roofs also?
You're talking about that brand called Porotherm, which is a good brand. I think the U value of that, we have tried to use it on walls and we have found it gives good U value. I'm sure the same can be achieved on the roof. At least we have not tried it on the roof. I don't know, it might require a framework for it to be installed. But otherwise, when porotherm hollow blocks are used in the walls, they have been found to have good low thermal transmission. So they are definitely good, yes.
We have another participant, Dr. Girish Sapra. What kind of certifications are required for conducting green energy audit?
So far, there are no certifications from the central government as far as green audit is concerned. But if you're doing energy audit, then you have to have a certified BE certified energy auditor. And if you're the other green aspects also, as much as possible, if you give benchmarks from the national building standards and so on, that is what is helpful. But at present, there is no audited. There is no certification for green audit as such as a whole. Only for the energy audit it exists.
I'm just sharing the email ID of the speaker. Anyone has more details, or you want to get in touch with her, or any project, something you may.
Dominic, can I take a minute?
Yeah, please.
Yeah, Dr. Roshni, excellent presentation. Thank you very much for a very in-depth analysis, right from zero level going up to the topmost level as such. You have vividly brought around all the aspects required for green built environment. You have touched upon energy, you have touched upon water, waste, zero waste, indoor environment, quality, material. Only one question: the watershed treatment which you talked about in a place in Aurangabad. Where have you carried out this experiment, ma'am?
It is in Indapur. It's in Raigad.
Raigad district. Okay.
Raigad district.
Okay.
Yes.
Ma'am, can we have your presentation, please?
Yes, sure. I can share the presentation.
Thank you very much. Very kind of you. I have no questions. Dominic ji, back to you.
No, what I'm saying is, though all the other participants are there, it's very interesting. If you can give me something, a subject very specifically, even a holistic, it's a huge subject that, to present. If you can break into 2-3 sessions, where I would definitely like to see all the developers and the builders, we tell them how the construction innovation happening and the net zeros of 2070, what our Prime Minister said, and how we as an architects or professionals can contribute. So if you can give me some subject, some theme, break it into 2-3 sessions, so which will definitely help the users and developers to attain and understand your perspective on those. So this is my suggestion. As a focus, we are doing many programs. There's always, every day, there are some webinars happening. But this is something very close to my heart on this subject, and many are really interested. But being Monday, beginning of the week, and and the timing also it may not, not suited to many to register. That's what I feel. We have a huge database. I recommend, like, I call it Sunday learning. It could be a Sunday learning for 45 minutes, just, coming at 11 o'clock, finished by 12:15. That could be one, or it could be a weekend, like Friday evening from 4 to 5, or it could be even from 6:30. It depends on your convenience. But if you could give me the timing which is suitable to all the attendees who are finishing the work, they can relax and listen. Even if it is even the evening after 7, I am fine with that. Just let's see, experiment in the next session that you would like to come on. Let's not do it on Monday evening, definitely, because may not be suited to many. But weekends or Sunday learning, we do that. Let's catch up for a Sunday learning. We just like very relaxed, comfortably. A lot of students also would like to join for this kind of session. So my recommendation to Rumi and the Darawalajis and all, if we can have a program of Mumbai chapter, something very interesting of such nature.
Certainly we can look into, sir. Certainly, Mr. Domain.
Rumi sir, over to you for vote of thanks. And I have mentioned Roshni's mail ID. We will definitely, if any participants who are interested, they can contact her. Over to you, sir.
Thank you very much, Dominic ji, HND sir, and all the participants. The focus name itself, it's a forum of critical utilities and services. So it's a very apt, and I think so today's program, it has touched upon all the facets of not even construction. It's a very wide thing which we have addressed in. It's an integrated approach. So it's not only site, it's not only water, it's not only waste. So that's why the name itself, we had said it's a holistic approach. So with that, I really appreciate and thanks Dr. Architect Roshni for taking up the time, investing her time to put all the things together and put it across to us, which was really enlightening and very informative. And I'm sure, as Dominic ji, you have been saying, she has done a lot of research on the walling materials, which I'm aware of it a little bit, not much. But she has really get into a deep dive that if you have to do a wall, maybe a new or a retrofit, how one can go about it. And I'm sure this is really an eye-opener to all the stakeholders in the industry. So maybe we can take it, you rightly said, we can take up some small portion. So definitely we look into it. Yeah, the timing and all that thing, definitely we will coordinate. And let's hope to have a program wherein we have more engagement, more participants attending, and more outreach happening to the various stakeholders from various disciplines, I would say. So once again, Roshni, thanks very much on behalf of the team, and my personal thanks also. So it was really enlightening thing to hear you and to see all the information which you presented. So thanks very much.
Thank you so much, Roshni. Thank you very much.
Thank you, Dr. Roshni. Thank you, Dominic. Thank you, Rumi.
Thank you.
Thank you. Wonderful.